So there's another way to solve the same question where it gave us the hyperbolic cylinder x squared minus z squared minus 1 equals 0, and we have to find the points closest to the origin. So we know this is our hyperbolic cylinder, and to use Lagrange multipliers, if we had another surface, say a sphere, that's centered at the origin, so just call that f of x, y, z is this sphere. At the intersection points, the gradient of the sphere would equal a scalar times the gradient of this g function, which is our hyperbolic cylinder, because they intersect and they have the same slope. So we can make our hyperbolic cylinder into this equation, g of x, y, z equals x squared minus z squared minus 1. And for our sphere, which is our f of x, y, z function, it's just, we'll use a constant, a squared equals x squared plus y squared plus z squared. And we need to find the gradients. Yeah, so find the gradient and use the Lagrange multiplier. So the gradient of our f function is 2x. You just found the derivative in respect to x, y, and z. So 2xi plus 2y plus 2zk. And then for our g function, because it's multiplied by lambda as a scalar, so 2x lambda I, and then there's no y value, minus 2z lambda k. So we know the gradients have to be a scalar multiple of each other. So if we set this up as our y value, or our I values of the vector have to be the same, so 2x equals 2x lambda. We know lambda has to equal 1. And we know there's no y value, so y equals 0. And so if lambda equals 1, right, we found that lambda equals 1. We plug it into our z values. 2z equals negative 2z lambda. And we know lambda equals 1. That means you have 2z equals negative 2z. And this only works if z equals 0. So given that, we have the point x, 0, 0. And because like we know from back here that x equals x lambda, and lambda equals 1. So that means x also equals, x can be anything, sorry. So, but we know back in our original equation, from our original hyperbolic cylinder, x squared minus z squared minus 1 equals 0. We know z is 0, so x squared equals 1, so x equals plus minus 1. So that's our points, 1, 0, 0, and negative 1, 0, 0. As our points closest to the origin, that'd be these 2 points.